All section in solutions. And what we're going to talk about, we're going to start by talking about what a solution is. And a solution is when one substance is dissolved in another substance. And an example of this would be salt water, right? Or even an Alka-Seltzer tablet where the Alka-Seltzer tablet is dissolving. It can be a liquid, a gas, or a solid, or a mixture of any one of them. So an example of a soda, right, where there is a gas dissolved in a liquid. So that would be like the carbon dioxide dissolved in the soda. That is an example of a two state of matter solution, a gas dissolved in a liquid. Now, solutions are made of three different parts. These are three vocab words which you must know. And you have to know these because if you don't, you can't read the questions. So if a question is being asked about a solute or a solvent and you don't know which one is which, you can't answer the question. So to help you with this, I'm going to use salt water as my example. So the salt in the salt water is the solute, the substance that is dissolved. The water in the salt water is the solvent. Well, that's not very pretty, is it? The solvent. Let's see if we can fix that. Let's see if we can make that prettier. Okay, and then finally, we go back to the whole thing of the salt water, which is the solution. All right, so the salt is the solute, the water is the solvent, and the two together makes the mixture of the solution. Now, finally, for today, we're going to talk about alloys, which are mixtures of metals. And they're made when the metals are in molten, melted, and so they're liquid. So two examples of this would be brass, which is a mixture of copper and zinc. And this was made during a time in the 1800s and the 1700s when people were molding metals by hand and making art, basically art pieces out of them that weren't art, they were useful. So, for example, military buttons or candlesticks, or they were making door handles or decorations for door, like a lot of the functional pieces in everyday living that was formed out of artwork, and there was metalsmiths who were doing this. So brass is more easily formed into these pieces than copper or zinc. And so therefore, the mixture of the two, copper and zinc, were more pliable for these artists to work on these things that are used in daily living. Today, we stamp out the artwork in our daily pieces, and we have machines that do this work for us. So the fact that it is more easily used is irrelevant to our function, to our producing these items, producing doorknobs, producing these things. So we don't really care whether it's a mixture or it's pliable or anything. Only artists, actual artists, would use brass, or and so that's a different thing. We don't need it today as in our daily items. Steel is a whole different ball game. So back in the early 1900s, like around 1900s and the 1880s, especially in the 1880s, when the Industrial Revolution was occurring, they were building buildings out of steel, multi-floor buildings out of iron. And iron has two major problems. They were also building bridges out of iron, and it has two major problems. The first is rust. Big problem. Corrosion, rust. So this was a major problem for bridges because they're obviously out in the air, right? The second problem is rust has an extreme thermal expansion issue and contraction issue. So this is not it's not as much as I'm showing you, but it is a problem over time. Small amounts, I'm saying it's extreme for metal, but it's tiny relatively to what I'm showing you. But this is thermal expansion. So in heat it expands, in heat it expands, and in the cold it contracts, right? Over time, that expansion and contraction around the holes that are being drilled for the bolts and around where it's being soldered, the pieces are being soldered for the buildings. Over time, the expansion and the contraction of these pieces is very wearing on the pieces that are construction to make these multi-level buildings. So like 8 stories, right? And after time, as in like 20, 30, 40 years of expanding and contracting, when the temperature in New York City and the temperature in Minneapolis is going from negative 20 degrees Fahrenheit to 100 degrees Fahrenheit, expansion and contraction, and then you add in rust, which is due to water and oxygen, the buildings were starting to experience great deal of wear and tear. And some of them were actually experienced like floors breaking and the bridges were falling down. And so this was a problem. So what happened was they developed steel. I mean, there was a lot of replacement going on and rebuilding and buildings being condemned, but they replaced it with steel. And what happened was they added this less than 2%. It's actually like 1.86% carbon during the molten stage of the iron forging when they were making I-beams. They added this tiny little percent of carbon to the iron and they create steel. And just adding this little bit of carbon reduces the rust to far less, almost zero, might even be zero. I think it's less than less, but not zero, and minimizes the thermal expansion and contraction. And so what it does is it extends the life of these girders to basically as long as we need them. So this tiny little mixture created these characteristics and extended these characteristics to make it much better for human use. So this is what an alloy does. It creates like super metals by expanding the use of already characteristics that are there. It just eliminates some characteristics and builds up others. Okay, that's it. That's what I've got for today, right? Solution mixtures and alloy mixtures, okay?